In this lesson, we're going to use our previous knowledge of the regular trig graphs and our new knowledge of the inverse trig graphs to help us answer a set of questions. So we're going to look at 1, 2, and 3 across here. Number 1 asks us to find where the sine graph is equal to a half, or what angle has a sine or a y-coordinate of a half. Notice there's no other information given, no restrictions. But look at number 2. Number 2 is the same exact question as number 1, but they're telling us that we can only give answers that fall between 0 and 2 pi. Okay, look at 3 and how it compares to 1 and 2. Well, 1 and 2 are just the regular sine graphs, but number 3 would be the arc sine or the inverse sine because of the word arc. So how are these answers going to be similar yet maybe different? Well, let's answer question 1. So this is saying to us, without considering the arc graph, the inverse graph, where does the angle have a y-coordinate of 1/2? What angle has a y-coordinate of a half? Well, if we kind of just think about the full unit circle, just kind of ignore that, this is highlighted because that's really going to go for this question right here. So if you have your regular unit circle that you can access and put in front of you, that might be better than kind of looking at this right here. So what angle has a y-coordinate of a half? I'm just going to draw a regular unit circle here. Well, we've got a y-coordinate of a half here and here. And then we can keep going around and around and around without ever stopping. So one of my answers, x equals, one of my angles is going to be pi over 6. The next time I have an answer for this question is going to be over here at 5 pi over 6. Well, I'm not going to restrict my answers to anything, so the next time I'm going to have a pi over 6 is when I go all the way around and back up to pi over 6. So that's going to be 12 pi over 6 plus 1 more pi over 6, or 13 pi over 6, comma. All right, what happens if I go all the way around 12 pi over 6, but then I add 5 pi over 6 more? Well, that's 17 pi over 6. I could keep going around and around and around, getting all these positive answers. Likewise, I could go back in the other direction and get the negative answers as well. So I'm just going to say that I have no restrictions on how many answers I'm going to have here. So I'll just indicate that with a dot, dot, dot. So here we're going to have an infinite number of answers. All right, well, let's look at number 2. 2 is the same question, but they only want us to give angles between 0 and 2 pi without going repeatedly around. Or don't give any negative answers because these values are positive. Well, if we look at the answer to this question based on these restrictions, all we're going to be able to give are the first 2 solutions here. So for this question, I'd only have 2 answers, not an infinite number of answers. And just double checking, excuse me, just double checking, yes, these 2 answers would be numbers that fit between 0 and 2 pi. All right, let's look at the presentation of number 3. This is read as arc sine of a half, meaning what angle, because that's what arc means, what angle has a y-coordinate of a half? Well, because we're talking about the inverse function, I would think about this unit circle being restricted to quadrants 1 and 4. So if I would look at this unit circle, or this restricted unit circle, I would go, well, where is the y-coordinate? Because sine is y. Where's the y-coordinate? 1/2. Well, again, it's at pi over 6. So this angle, and there's no indication if I should use x or theta or whatever. So I'll just use x again. So this answer would only be x equals pi over 6. We would not give 5 pi over 6 because remember, 5 pi over 6 would be located over here in quadrant 2, but the arc sine graph has only the restrictions of quadrant 1 and 4. So this would only have one answer compared to these other ones. All right, let's do 1, 2, and 3 here. Notice everything is the same except for now my y-coordinate is negative 1/2. So, all right, what angles have a y-coordinate of negative 1/2 on your regular unit circle? Well, negative 1/2 is here and here. So if I wanted to erase these and take them out of my view, it looks something like this. Well, this angle right here is 7 pi over 6. And this angle right here would be 11 pi over 6, both having a y-coordinate of -1/2. Well, I'm not being restricted, so that just tells me I can keep going around and around getting coterminal angles. So let's go back to 7 pi over 6. Well, if I were to add 2 pi, 12 pi over 6 to 7 pi over 6, I get 19 pi over 6. Now let's start at 11 pi over 6 and add a 2 pi. Well, adding 11 and 12 gives us 23 pi over 6. No restrictions, so ... I would have an infinite number of solutions if the presentation of the problem was in this manner. All right, we'll look at this question compared to number 1. Now it's just asking for the y-coordinates of -1/2 as long as your angles only go 0 to 2 pi. So 0 to 2 pi means I'm only going to consider 7 pi over 6 and 11 pi over 6. So this answer would just be these two solutions. Okay, now let's look at the presentation of this problem. Now it's saying, I want you to consider the arc sine graph, not the regular sine graph, because there's no arc indication here, nor is there a -1. So I have to throw myself into what are the restrictions on the arc sine graph. Well, here's the arc sine graph. -1/2 would be here. I cannot call that 11 pi over 6. I'm not allowed to call this answer 11 pi over 6 because 11 pi over 6 would not be a number that fits between -pi over 2 and pi over 2. So we have to kind of think on our feet. Well, what's another name for 11 pi over 6? Well, if I went in a negative direction, that would be coterminal with -pi over 6. All right, so the presentation of the problem is going to throw us into, should we look at the regular sine graph or the restricted arc sine graph? All right, let's just do some more practice problems here. It says, find the exact value of each expression, if possible, without using a calculator. All right, I noticed that in all 6 of these problems, I'm dealing with arc functions, inverse functions. So I really have to think about the restrictions on each of these 3 graphs here. So arc cosine of 1/2. So this is saying to you, think about decoding it. What angle has an x-coordinate of 1/2? So we're talking arc cosine. We want to look at this graph. So where is the x-coordinate 1/2? Well, we know that this is 1 and this is -1. So where's the x-coordinate 1/2? Well, the x-coordinate's 1/2 up here. Just kind of like your regular unit circle. What angle is this? Well, this angle's pi over 3, and pi over 3 does fit between 0 and pi. So this answer would be pi over 3. So you could put equals pi over 3, or you could just do x equals pi over 3 if you're calling x the angle. You could use theta or anything you want here. Okay, go to the arc cosine graph. Where's the x-coordinate 0? So the x-coordinate 0 here. So if the x-coordinate 0 here, what's that angle up here? That's pi over 2. All right, let's see if there's any more arc cosine since I'm kind of in that mode. Okay, we'll come down to number 4. Where's the x-coordinate? What angle has an x-coordinate of -1? Well, -1 is over here. What does that angle measure? That's going to be pi. All right, nothing different really from the unit circle right now. Let's go to number 6. So instead of using ARC, we're using the -1, but it's the same thing. So what angle has an x-coordinate of -2? Well, if I come up here, this is x is -1, x is -2 is way over here. It's out of bounds. So our answer is going to be no solution. Because remember, the domain for arc cosine is -1 to 1, and -2 would be outside of this domain, so I wouldn't have an answer. If you did this on your calculator, second cosine, and put in -2, it'd give you error. All right, 3 and 5 are both arctan, so we're going to be focusing our attention on this graph right here. So what angle has a tangent ratio of y over x of 1? Well, we know from our work with the unit circle that the ordered pair right here at pi over 4 is square root of 2 over 2, and then the same. So if I were to take the y coordinate divided by the x, these are the same, I would get 1. So what angle has a tangent ratio of 1? Pi over 4. All right, this says what angle has a tangent ratio of square root of 3? Well, if I'm at square root of 3, that means y over x is square root of 3. So we might have to go back to our unit circle. I know that this value is positive and tangent is positive in quadrant 1. So let's just revisit the unit circle. This ordered pair here would be square root of 3 over 2, comma, 1/2. But if I took y and divided it by x, I'm going to get 1 over the square root of 3. So let me come up here to pi over 3. I know that ordered pair is 1/2 square root of 3 over 2. If I were to take y and multiply it by the reciprocal, I would get square root of 3. So my answer for this one is going to be x equals pi over 3. Okay. I'm actually going to add another problem because as I was doing this, I thought, you know what, it'd probably be better if we did arctan of negative square root of 3. So let's just put arctan negative square root of 3. Okay, let's say this is our problem. What angle has a tangent ratio that's negative square root of 3? So arctan means look at this restricted unit circle. Where would tangent be negative? Well, not in quadrant 1, but tangent would be negative in quadrant 4. Okay, at what angle is my y over x ratio going to be negative square root of 3? So either here or here. Chances are it's going to be symmetric with this point up here that had a positive square root of 3. So let's just go ahead and fill in this ordered pair. So that, that should be positive 1/2 and negative square root of 3 over 2. So y divided by x, or y times 2 over 1, is going to give us negative square root of 3. So my answer should be this angle right here. Well, you may know that as 5 pi over 3. But we don't want to give an answer of 5 pi over 3 because that number is not between negative pi over 2 and positive pi over 2. The coterminal name for 5 pi over 3 would be negative pi over 3. And going back and checking, negative pi over 3 would definitely be a number that fits between negative pi over 2 and positive pi over 2. So this answer can't be 5 pi over 3. It has to be named as its coterminal negative pi over 3. This can be a bit tricky, but it just takes practice. And then always going back and referring to, if the presentation of the problem is with arc, referring back to what is the restriction on the unit circle for those inverse functions, and then always looking back at the range as well. To make sure you're giving an answer that fits between here. We want to call it the right name. And in this last example, we didn't want to call it 5 pi over 3, but instead we'll call it by its other name, negative pi over 3. All right, just takes practice. All right, let's move on to another objective. This says use an inverse trig function to write theta, okay, I see theta, as a function of x. Use an inverse trig function. Well, what I see is theta. I see an adjacent side and a hypotenuse. I don't have information about the opposite side. So I think what I'm going to use is cosine, just the regular cosine function, not the inverse yet, and I'll take care of that in a second. So based on this right triangle, I know I can set up the trig ratio. The cosine of theta is equal to adjacent over hypotenuse. Let me go back and read the question. Did I answer it the way they wanted me to? Did I use an inverse trig function? Nope, that's not an inverse trig function. So to get theta by itself, to write theta as a function of x, to get theta by itself, I'm going to bring in an arc cosine. I'll use this notation. And this arc cosine is going to undo this cosine off of theta. But what I do to one side of an equation, I've got to do to the other. So these two will cancel. They undo each other. I'm left with just the angle. So theta is equal to the inverse cosine of the fraction of 4 over x. So let me go back to the directions. Did I use an inverse trig function? I did, because of this notation, to write theta is here, as a function of x. Do I have an equation with theta equals with the inverse trig function? Yes, I do. So practice number 8, using the correct regular trig function to set up a trig expression for theta, and then bring in the arc, the appropriate arc function. Here's theta. I've got opposite and adjacent. I'm thinking that's tangent. So the tangent of theta would be the fraction x plus 1 over 10. I have not used an inverse trig function yet, and theta is not by itself. Bring in an arctan on both sides of the equation. Arctan will inverse or undo tan, so theta equals, and I need an arctan here. So hopefully you found those problems pretty straightforward. Okay. All right, continuing on the back, here we've got some properties of inverse functions. Gets a little weird here. Okay, so we've got 3 situations going on. It says if x is a value between -1 and 1, and y is a value between -π/2 and +π/2, this looks like sine to me, then notice that here we have a sine on an arc sine. Okay, it's saying that sine of arc sine of x equals x. That my answer is x, which matches this value right here, as long as my x value fits between -1 and 1, which is the domain of sine. Okay, now compare and contrast this expression to, or this equation to this equation. Notice that arc sine is on the inside here. We do that first and then take the sine of arc sine. Here on the inside, we're not doing an arc sine, we're doing a regular sine. So as long as y fits between -π/2 and +π/2, if you have sine of some y value that's in the range of arc sine, then when you go to take the arc sine of it, your answer should be y, or just the same thing as what's in the problem. It gets a little weird because there's certain restrictions. Hang in there. All right, let's look at this next property. Again, if x is between -1 and 1, but the y's or the answers are between 0 and pi, now we're talking arc cosine. Then if you have arc cosine first of some x value that fits in the domain of arc cosine, then when you go to take the cosine of that answer, you're back to where you started. You're back to x, meaning your answer should be the same as what's in the problem, as long as x is in this domain. If it's not, we'll tackle that later and see what happens. All right, for this one right here, what if we're taking the cosine of some angle y that's between 0 and pi, and then after you get that answer, you do the inverse of that, then your answer y is the same as your input value y right here. All right, and last but not least is the tangent property. Hang in there. Now it says x can be any real number, but if your y is between -π/2 and +π/2, and actually I think that might be a typo. I don't think we can include -π/2 and +π/2 because that's part of the range of arctan is to exclude those asymptotes. All right, then it says that my answer is x, which is in my problem, as long as x is any real number. If I'm doing the arctangent of x and then the tangent. All right, if I'm finding the regular tangent of an angle, as long as y fits in this interval, and I go back and do the arctan, my answer should be what's in the problem. All right, that was a lot. Let's see if we can put these properties into practice. It says, use the inverse properties, these, to find the exact value of the expression, if possible. So, no calculator usually when they say those words, exact value. All right, so for number 1, arctan. Arctan's on the inside, tangent's on the outside. So this problem fits this first property. arctan of x, is 25 any real number? Yes, it is. Okay, then that means that my answer should be 25. When I go back and take the tangent, these two undo each other, so I should be back to 25. So 25 is a real number, so my answer should be 25 just because of this property. You can double check this on your calculator and do tangent, arctangent, so tangent, and then inside arctangent, second tan, and then do 25, close your parentheses twice, and you should get what you started with. And that's because 25 is a real number. Okay, let's look at number 2. So I'm dealing with the arc sine situation, so that'd be this property. So arc sine of -1. All right, so I'm coming up here. I have 2 to choose from. Arc sine's in the middle. It's the inside function. Okay, I want to focus on my x. So is -0.1 a number between -1 and 1? Yes, it is. If x is a number between -1 and 1, and I go back and take the sign, these two will undo each other. My answer is -0.1. Okay, you can check that on the calculator and you should get that answer. All right, let's look at 3. We're talking about the arc cosine property. So arc cosine is in the middle, or the inside function, what you do first. So that would be this case, not this one, because that's cosine y. So is x a number between -1 and 1? Well, -2 is not between -1 and 1, so we have no solution here. You can double check that on your calculator. What's cosines on the outside? Error, quit, no solution. Okay, notice in 4, 5, and 6, now I've kind of switched the order. I didn't put the inverse function in the middle or on the inside. So now we're going to be talking about these properties right here down this column. Okay, arc sine of sine of 4 pi over 3. So let's come up here to this first one. All right, it says sine of y. The answer is y as long as this y is between -pi over 2 and +pi over 2. So sine of 4 pi over 3 is not between -pi over 2 and +pi over 2. So remember, arc sine is this, quadrants 1 and 4. Well, where is 4 pi over 3? Well, 4 pi over 3 is down here. Okay, so my answer cannot be 4 pi over 3. My answer has to be something different. All right, so how we're going to find this is we'll figure out what sine of 4 pi over 3 is. Well, the y-coordinate at 4 pi over 3 down here should be -√3 over 2. This is a little more tricky. So now I'm going to come here and go arc sine, okay, of sine 4 pi over 3 is -√3 over 2. So what I just did was found the sine of 4 pi over 3 and put it here. So my answer is not going to be 4 pi over 3 because that doesn't fit between -pi over 2 and +pi over 2. Okay, so for me now, I'm going to go to my arc sine graph, which is here, and I'm going to look for a y-coordinate of -√3 over 2. Well, that's going to be right down here. This angle also has a y-coordinate of -√3 over 2. What's the name of this angle? We don't want to call it 5 pi over 3. We want to call it its coterminal name, -pi over 3. So that's the answer for that problem. It's a little tricky. It takes time. We want to quickly say 4 pi over 3, but that can't be the answer because 4 pi over 3 is not an angle that's in quadrant 1 or 4. All right, let's look at 5. All right, so now we're talking about this situation right here, not over here, cosine of 3 pi over 2. So let's double check 3 pi over 2. 3 pi over 2 does not fit between 0 and pi. So my answer will not be 3 pi over 2. It won't be the same as what I have here. So what's another name for 3 pi over 2? Okay, well, I don't know if we can say another name for 3 pi over 2 because that's -pi over 2. Let's work this one out slowly. So let's figure out what this answer is on the inside. Keep the arc cosine. Okay, cosine of 3 pi over 2. Well, 3 pi over 2 is down here. The x-coordinate is 0. So cosine of 3 pi over 2 is 0. So now let's put ourselves in the restricted, now we're doing an arc cosine, a restricted arc cosine graph. So what angle between 0 and pi has an x coordinate of 0? Here's 0, so the angle up here is pi over 2. Notice that pi over 2 is not the same as 3 pi over 2, nor was negative pi over 3 the same as 4 pi over 3. We want to kind of quickly take these off and say our answer is 3 pi over 2, but we have to be aware of restrictions with these inverse functions. Hang in there. All right, let's look at this problem. We're back to sine. Sine, not the arc cosine, or excuse me, not the arc sine, but just the regular sine is on the inside function. So we're talking about this property. Okay, so y, which is 2 pi over 3 in my problem, 2 pi over 3 does not fit in quadrant 1 or 4. So let's think about where 2 pi over 3 is. 2 pi over 3 is right here. That's not part of our restricted arc sine range. Okay, so we have to actually work this problem out. My answer will not be 2 pi over 3. So arc sine, what is the sine of 2 pi over 3? Well, the y coordinate is square root of 3 over 2. We have a new problem that we can now look at our restricted inverse sine graph. What angle has a y coordinate of square root of 3 over 2? Well, that would be this angle up here. What is that angle? That angle is pi over 3. All right, so it's important to have these properties in front of us so that we can take our time to analyze, is my answer to my question going to be the same as what's in my problem when I have both a tangent and an arctangent, or a sine and an arc sine, or a cosine and an arc sine in the same problem? All right, so yes, you'll be given these properties. They're on your memory enhancer sheets, your formula sheets. All right, let's come down here to the last few questions, see how the directions change and what should we do here. All right, find the exact value of the expression. Hint, make a sketch of a right triangle. So again, finding an exact value typically means no calculator. So let's use right triangles to help us get the answer. And remember, you can always do these, you can check your work by putting these problems into your calculator. All right, find the exact value of the expression. Okay, notice here that I got a cosine of an arc sine, different than, a double up of the same type of function. So cosine, arc sine. All right, so these two functions are not the same. Sketch of a right triangle. So let's go to the inside first. Arc sine of 24 over 25. Well, I know arc sine, and then this value is positive, not negative. Arc sine is only going to be in quadrants 1 and 4. Sine means y. This is a positive y. So I'm going to put my right triangle in quadrant 1. All right, so what angle has a sine ratio? Now, we're not talking about the unit circle. We've got to change our a strategy, I guess. Right triangle. So arc sine 24 over 25. So here's the theta, the angle. Okay, sine is now opposite over hypotenuse. So 24 here, 25 here. Remember, no unit circle now. If I did Pythagorean theorem to find this missing side, I would get 7. So now let's go back to the question. I just drew a right triangle for arc sine of 24 over 25. So I'm done with this part of the problem. That's this angle, having a sine ratio of 24/25. Now let's go to the outside part of this problem. What is the cosine at this same angle? So this whole thing is theta that I drew. What is the cosine of theta? Well, cosine is adjacent over hypotenuse, so my answer is going to be 7 over 25. Hang in there. All right, number 2. We're still trying to make a right triangle, so we look on the inside. Okay, arctan of a negative number. Okay, I think arctan's here or here. Tangent ratio being negative means that I would be down here in quadrant 4, so that's where I'm going to put my right triangle. Here's your theta up against the origin. So the tangent ratio is negative 12/5. So negative 12, this is negative, and then adjacent is 5. All right, so what's the cosecant at this angle? Well, let me go ahead and finish Pythagorean theorem because I think I'm going to need the hypotenuse for cosecant. So using Pythagorean theorem, we're going to get 13 for the hypotenuse. Okay, so we use this information to draw the correct right triangle in the appropriate quadrant. Now, what's the cosecant at this theta? Well, remember, cosecant is going to be hypotenuse over opposite. It's the reciprocal of sine. So my answer is 13 over negative 12. 2 more. Let's draw a right triangle for arc tangent of negative 3/5. So again, we're in quadrant 4. So this was quadrant 4 as well because of this value. So this is quadrant 4. Right triangle. This is always theta. Tangent ratio, opposite over adjacent. So this would be 3, but it's negative, and this is 5. Do Pythagorean theorem, you're going to get the square root of 34. Now, let's answer the secant question. Secant is hypotenuse over adjacent. So hypotenuse over adjacent. My answer to this problem, square root of 34 over 5. All right, I recommend you guys trying this one on your own, pausing the video, and then come back to see how you did. Intentionally think about, why am I in quadrant 1? Because the tangent value is positive. Tangent, so what angle has a tangent ratio of 5/8, opposite over adjacent? Pythagorean theorem gives square root of 89. And actually, I didn't even have to do the hypotenuse because now I just want to find the cotangent. And the cotangent is just going to be the reciprocal, 8/5. So really, Pythagorean theorem wasn't necessary because I never needed the hypotenuse to answer the cotangent question, which is adjacent over hypotenuse. Yeah, I know this is a lot of information, a lot of different information with a lot of details, but it just is going to take practice and a lot of dialogue of back and forth talking about these to get better at these.